Kia ora koutou, Reese from QuickSense here, and today we're looking at enlargement. In this question we're asked to find the center of enlargement for the new square, quadrilateral, A-B-C-D. And immediately you might be drawn to 1, right? The center, right? That makes it seem like we're looking for the center of the new shape. But what we really mean by the center of enlargement, if I have a, let's go with something like a triangle over here, and I have the center of enlargement being this spot, then what I'm doing is I'm looking at straight lines that pass through the vertices of the original. Okay. All right, all of these are proportional. And then they end up at the new vertices. Right? In this instance, this point is my center of enlargement, even though it's not in the center of the new shape. So which one of these 1, 2, 3, 4 satisfies that? Well, we can look through it, right? So 1 and 2 we can immediately discount, yeah, because they're both to the new shape is to the left-hand side, and these are both either in the center or to the right-hand side of it. So if it were 2, for example, well, that would mean that the new A would be somewhere over here, and it's obviously not. So that leaves us with 3 and 4. And so what I'm going to do is try my best to draw some straight lines from 3 through this point here, and see, does it connect to the new vertices, the new vertex. And as we can see, it actually misses it by a considerable amount. So it's not going to be 3, so let's just double check 4. Well, that works. Let's have a look at B now. And remember, I'm using software here, so it might not be perfect. Okay, so it's not perfect, right? You're going to use a ruler, hopefully to make sure that the straight edge is straight. But I'm confident that from point 4, the straight lines passing through each of these vertices is connected to the corresponding new enlarged shape. So which are the following points? Well, it's point 4. Now this next question is going to seem a little bit tricky, but we're going to use a little algebraic trick to hopefully make it seem a little bit easier, or at least sit easier. So we've got a triangle here. And with this triangle, we are scaling it up by 3 and then by 0.75. So what does that mean? Well, if I have a size of 3, 3, 3, with the new triangle, if I scale it up by 3, it's going to have 3 times 3 over here, so 9 and 9. So what I'm looking at, let's just make this a little bit smaller. So what I'm looking at is a triangle, and I don't know what kind of triangle it is, but I know it's got one side, x, it could look like this, or it could look like any triangle. But I'm scaling it up by 3, and then 0.75. So what does that mean? Well, that means that I take that side, x, and I multiply it by 3, and then I multiply it by 0.75. And I end up in the end with 9. So what is the original size? Well, if we simplify this, x times 2.25 equal to 9. X is equal to 9 divided by 2.25, which is equal to 4 centimeters. So my original side over here, well, that was 4 centimeters all along.